Today, we're not just going to scratch the surface of JavaScript. Nope. We are digging way down, right to the very roots, to really understand what makes this language tick. You know that feeling, right? You write some code, it works. But you don't exactly know why it works. You're not alone. A lot of JavaScript's behavior, from how it handles variables to how objects talk to each other, can feel kind of weird and counterintuitive at first. So that's what we're here to do. We're going to pull back that curtain. We're going to look at 4 core concepts that really answer the why behind so much of your code. By the end, we'll turn that feeling of magic into a solid understanding of mechanics. Let's do it.
Okay, first up, iteration. Pretty much every program we write is about processing data. So the way we step through that data, piece by piece, is absolutely fundamental. Let's look at the standard pattern JavaScript gives us for this.
This is a classic idea in computer science, the iterator pattern. Instead of trying to, load a massive data set into memory all at once, which could be super slow or even crash your program, it gives us a standard way to just ask for the next piece of data when we're ready for it. Think of it like a conveyor belt, bringing you one item at a time. And JavaScript gives us some fantastic built-in ways to work with these iterators. The for.of loop is your classic, right? It just processes items one by one. But then you've got the spread operator, those 3 little dots, and it is so incredibly useful. You can use it to unpack all the values into a new array, or even pass them as separate arguments to a function. Super versatile. The best part is, so many of the things you use every day are already iterables right out of the box. An array is the perfect example. Because it's an iterable, you can just drop it into a for.of loop and step through each value. No fuss, no special setup. It just works. And hey, it's not just for arrays. Strings are iterables too, which can be surprisingly powerful. With one simple line using that spread operator, you can instantly break a string apart into an array of its individual characters. It's just a really clean and elegant shortcut to have in your back pocket. All right, on to our second pillar, closure. Now this is one of those concepts that really feels like magic at first, but it's actually the bedrock for how functions in JavaScript remember the world around them.
So what does that really mean? It's all about memory. A function can close over the variables from the environment where it was first created, and it holds on to that connection, that memory, no matter where you end up calling that function later on.
Let's look at a classic example to make this real. You have an outer function, greeting, that returns another function, who. That inner function closes over the MSG variable from its parent. So even after greeting is done running, that MSG is preserved. It's like the inner function carries around a little backpack with all the variables from the place it was born. Now, this is the most important part. This is the real secret sauce of closure. It is not just taking a snapshot of the variable's value at one moment in time. It's a persistent, live link to the variable itself. And that means if that variable ever changes, the function will see the new value. And because it's a live link, things get even more powerful. The inner function doesn't just get a read-only copy. It can actually reach out and update that closed-door variable. So you can have a variable like count, and with every call, the inner function can update it. And because of closure, that updated value is preserved for the next time it's called. This is how we create persistent state. And here's the proof in the pudding. Look, we can create 2 totally separate counters, ink by 1 and ink by 3. Each one gets its own private preserved count variable, all thanks to closure. And you can see how calling ink by 1 has absolutely no effect on ink by 3's state. They are completely independent. That is the power of closure for creating private encapsulated state. All right, let's wade into it. We're going to tackle one of JavaScript's most powerful and, let's be honest, most confusing features, the this keyword. My advice, forget whatever this means in other languages you might know. In JavaScript, this is a whole different animal. It's all about context. This right here is the most important distinction you can make. Scope, which we just saw with closure, is static. It's locked in the moment you define a function. But this is dynamic. It can be different every single time you run the exact same function. It all depends on how you call it. So check this puzzle out. We have one single function, assignment, but we call it in 3 different ways, and we get 3 totally different outputs. How is that even possible? The answer is all about the call site. Where and how was it called? Okay, let's break it down. When you just call the function directly, this defaults to the global object.
But when you call it as a method on an object, like homework.assignment, this becomes that homework object. And if we want to get really specific, we can use a method like .call to explicitly say, hey, for this one time, this should be this other object. So the key isn't where the function was born. It's all about how it was invoked. Now for our final pillar, the one that really brings a lot of these ideas together, prototypes. This is JavaScript's core mechanism for how objects link to other objects, letting them share behaviors and properties through a powerful system called delegation. Think of it like a chain of command, or a fallback system. When you try to access a property on an object, JavaScript checks that object first. If it's not there, it doesn't just give up. It follows this hidden link up to that object's prototype and checks there. And it'll keep walking up this prototype chain until it either finds what it's looking for or it runs out of links. And this is where this and prototypes do a beautiful dance together. Imagine you have two separate objects, JS homework and math homework. They can both be linked to a single shared object that holds common methods, like a study method. So when we call study on JS homework, JavaScript doesn't find it there, so it delegates. It looks up the prototype chain and finds it on the shared homework object. And here it is, the big aha moment. Even though the study method lives on the shared prototype object, the dynamic this keyword points back to the object that started the call, in this case, JS homework. This is what makes the whole system so incredibly flexible. It lets tons of objects share a single method, but it guarantees that the method will always operate on the correct object's unique data. It's brilliant. So there you have it. Iteration gives us a standard way to process data. Closure gives our functions memory. The this keyword provides dynamic context based on how a function is called, and prototypes link objects together so they can share behavior. See, these aren't magic tricks at all. They're just the core, predictable mechanics of the language. You know, understanding these roots is really the key to leveling up as a developer. It lets you move beyond just knowing what your code does to truly understanding why it works the way it does. So the next time you're coding, I hope you keep asking that question. Why? Thanks for joining me on this deep dive.